Hello, we are in Chapter 7, Section 7.4, Logarithmic Functions. In this video, we are going to go over an example of graphing a logarithmic function. So recall that this exponential function is 1 to 1. This is actually 2 to the power of x. When we were graphing that earlier, we were looking at the table of values. That means raising 2 to different powers and obtaining ordered pairs that corresponds to the points on the graph to then join them with a nice smooth curve. And that was the result. The domain of this function was all real numbers, the range was the open interval from 0 to infinity, and the horizontal asymptote was the x-axis. That means the line y equals 0. Now recall that to obtain the graph of the inverse function, we reflect the graph of the original function across the line y equals x, or we simply swap the components of the ordered pairs, swap the coordinates of the points on the graph. So by doing that, we get the following points: 1/8, -3, 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. And when we join those points with a nice smooth curve, we obtain the graph of the inverse function. And that inverse function, of course, here is the logarithmic function with the same base. We will call it f of x equals log base 2 of x. So that second table of values is really the table of values for that function. And we can examine its properties. The domain of this function will be the range of the inverse function. That means the range of the exponential function, which was 0 to infinity. Well, as you can see, the x coordinates of the points on that green graph start from a little bit to the right of 0 and go to the right to infinity. The range of this green function, of the logarithmic function, is all real numbers. As you can see, the y coordinates of the points range from -infinity to infinity. And another observation is that after reflecting across that line y equals x, the horizontal asymptote of the original exponential function became the vertical asymptote for the graph of the logarithmic function. So that vertical asymptote is the y-axis, whose equation is x equals 0. Similar procedure can be used to graph any basic logarithmic function simply by reflecting the graph of its corresponding exponential function with the same base across the line y equals x, or simply by swapping the columns of the table of values to obtain some guide points on the graph of the logarithmic function.